Hey, everybody. So we're going to continue with our parade of identities and formulas. So this should be a pretty quick one. This will be our product to sum formulas. And so these are going to be, as they sound, like formulas that we can take products of trig functions and turn them into sums of trig functions. So what I've got written here right now is a couple of our sum and difference formulas, the ones for cosine. So I've got these two, the cosine difference formula and the cosine sum formula. And we're going to do a little trick here, or just a little maneuver. I'm going to add these two equations, right? Because something interesting happens, right? So notice we've got cosine of alpha, cosine beta, plus cosine of alpha, cosine beta. That gives us two of those. But for the sine terms, sine alpha, sine beta, minus sine alpha, sine beta, those cancel out. So we end up with simply 2 cosine alpha cosine of beta. And over here, we've added them together. So I've just got cosine of alpha minus beta plus cosine of alpha plus beta, okay? And this gives us, this is the first of our product to sum formulas. Notice what we have. We've got the product of two cosines, and we've turned it into the sum of two cosines. So why don't I start a little collection of these? And this is the only one I'm going to derive. I'm just going to write the rest right now. That's more or less an M. The other ones are derived in very similar ways. We're taking, where did that line come from? Anyhow, so we're taking known formulas and creating, new instances of them with a little bit of manipulation. We get different abilities, right? So this is another one of those tools we're going to have in our toolbox to manipulate our trig functions, right? So there are plenty of cases out there where it's nicer to have a product than a sum, or vice versa. And this gives you one possible way to do this, right? This is most convenient for taking a product and turning it into a sum, because there's no real conditions on these two angles to get this, right? If you had a sum, you'd have to be really clever to notice you've got the difference and the sum of two angles to do this. I mean, you can always come up with that, but to notice that they're useful. So the other ones, we also usually do one other thing before we write these down. Let me, move this over. We just divide that 2 to the other side. So it's more typically written as 1/2 times all of this, right? By just multiplying 1/2 by both sides. So the rest of our product to sum formulas are sine alpha times cosine of beta. This will give us 1/2. We've got sine of alpha plus beta plus sine of alpha minus beta. Then we'll have sine alpha sine beta. We end up with 1/2 cosine alpha minus beta minus cosine alpha plus beta. And then finally, we'll have cosine alpha sine I'll put it sine beta. This is really a version of the second one. 1/2 sine alpha plus beta minus sine alpha minus beta. Okay, so there's our 4 product to sum formulas. I'm going to do a quick example with them. I've been mentioning a little later in the video series, we'll explore a lot of these with more detail. What's vitally important right now we don't memorize all of these. I certainly don't have them all memorized. Some that I use more than others, I tend to have committed to memory. What's really important is you know that they exist, right? You're doing a project, you get to something, and you've got a confusing combination of trig functions. Knowing that you've got a huge pile of trig identities to play with, you go look at a little collection of them and start manipulating them until you get what you want. Some of them we'll see show up all the time. For instance, we've already used in this series of lectures the Pythagorean identity all the time, right? That one certainly everyone should have it in their memory. Some of these start to get a little less common, though certainly very useful when they do come up. All right, so let's just do a quick example. Let's suppose I had this product, 11/12 pi times cosine of pi over 12. So this is our the first identity that we learned. So when we've got the product of two cosines, right, we take the cosine of the difference of those angles plus the cosine of the sum of those angles. So in this case, that's going to be cosine of 11/12 pi minus pi over 12 plus cosine of 11/12 pi plus pi over 12. Excuse me. So this is 1/2 cosine. So that's 10/12 pi. 11/12 minus 1/12 pi is 10/12 or 5/6 pi. And then we've got cosine of 11/12 plus 1/12 gives us 12/12 or simply pi. So let's see, 5/6 pi. That's going to be, so just a reminder on our unit circle. So, whoops, that's not a circle, that's more of an ellipse. Let's see if we can get this. There we go. 5/6 pi, right? So starting standard position, that's somewhere over here, right? The way I think of these, I remember that 1/6 pi, like I know that first quadrant of the unit circle, and I know that 1/6 pi, or pi over 6, has x coordinate √3 over 2, y coordinate 1/2. This one's just in the other direction, negative √3 over 2, 1/2. And so by symmetry, right, there's a pi over 6 sitting there. That's really what we're doing. Or you can think of these little triangles being the same. In any event, that gives me the cosine of 5/6 pi, negative √3 over 2. And then cosine of pi gives me plus -1. And if we do a little bit of algebra, there's a lot of different ways we could write this down. I ended up with negative √3 plus 2 over 4. Okay. Now, I've mentioned in the past, we don't use these primarily to compute interesting exact answers for sines and cosines. They're more often used when we've got these things and they're part of a function, or we're trying to solve an equation, and we'll do exercises in just a couple of videos. We have just one more set of identities to go through, and then we'll start really putting these into practice in somewhat more realistic situations than this. And then certainly down the road in your mathematical/scientific career, these things will come in handy. Okay, that's it for this one. Thank you, everybody. I will see you